In Part 1, a formation of 3rd generation F-4 Phantom II attack aircraft attempted to suppress an enemy S-300 air defense site. Flying low in tight formation, they baited the engagement radar into revealing its position, then launched anti-radiation missiles in a daring attack run. But they paid a heavy price. 3 Phantoms were shot down, while scoring only a single hit on the engagement radar. Even when caught off guard, the S-300 proved to be resilient. But now, the attacking team raises the stakes. Instead of aging 3rd generation fighters, they are sending in one of the most capable 4th generation attack aircraft of its era. The F-16 Fighting Falcon. More modern and superior compared to the F-4 in almost every aspect. 3 F-16s are now tasked with the same mission: to suppress the enemy air defenses. The formation approaches spread across several kilometers. Unlike the earlier Phantom strike, the aircraft do not fly as a single group. By separating the formation, the pilots improve their survivability while observing the radar environment from different angles. To understand the next phase of the engagement, we need to examine the F-16 attack profile in more detail, as it is significantly different to the F-4 attack run. The F-16s are armed with AGM-88 anti-radiation missiles, precision weapons designed to home in on enemy radar emissions. In addition, they carry unguided CBU-87 cluster bombs. Each weapon disperses more than 200 bomblets over a wide area, saturating the target zone to maximize damage against everything on the ground. After a low-altitude approach, the formation executes a rapid climb. Anti-radiation missiles are launched first, in opportunity mode without an actual target. While in flight, they scan for radar emissions and home in on them. This is a key difference to the F-4 attack run, that had to bait the radars into activation first. With the radars put under pressure by the HARM missiles, the F-16s continue climbing to increase the effective range of their much more devastating cluster bombs. The onboard computers determine the ballistic trajectory of the bombs before release. Unguided and only fin-stabilized, the CBU-87 canisters with cluster ammunitions are then lofted towards the SAM site. Now to the execution of the plan under realistic conditions. Having reached the island undetected, events now unfold in rapid succession. Let's begin from the attacker's perspective. The pilots check the distance to the target, 16 miles, the pull-up point. The formation executes a coordinated climb, rising into the coverage of the search radar. Radar warning receivers immediately detect the S-300 search radar. AGM-88 anti-radiation missiles are armed and launched in opportunity mode, forcing the defenders to choose between maintaining radar coverage or concealing their position. Initially, the defenders are alerted but unaware. Suddenly, multiple contacts light up on their consoles. They are very close. There is little ambiguity now. This is an attack. Frantically, the engagement radar is commanded to commence tracking of the hostile objects. The F-16s continue their climb, converting altitude and speed into additional range for their cluster bombs. Another warning. The S-300 engagement radar is now active. The pilots press on. Bombs away. The attack run is complete, but the most dangerous phase is not over yet. The F-16s must now maneuver back into the radar shadow before the SAM system can engage. At this stage, multiple F-4s have been lost before, but unlike the F-4s, the F-16s have another advantage: electronic countermeasures. Let's look at how an ECM pod like the LAQ-119 can delay an S-300 engagement radar from obtaining a solid firing solution. The radar emits bursts of electromagnetic energy and listens for the reflections from the target aircraft. By repeatedly sampling the aircraft's position over short intervals, it can estimate the target's trajectory and calculate a firing solution. Early ECM pods attempted to disrupt this process by transmitting a powerful signal on the same frequency as the engagement radar. This creates electromagnetic noise that makes it more difficult for the radar to isolate the aircraft's reflection and accurately track its position. The flap-lit radar tracks the F-16s, but struggles to generate reliable firing solutions through the degraded radar picture. Valuable seconds are lost as the operators attempt to separate genuine targets from the electronic interference. With the AGM-88s rapidly closing in, there's no time left to refine the tracks. The defenders commit and launch. The initial firing solutions are degraded and will need to be corrected during flight. The AGM-88s close in rapidly on the target area. The SAM site activates its short-range defenses. With only seconds to react, interceptors are launched. The strike package arrives. The dispersion of the S-300 battery is now its last remaining hope. The wide spread of the bomblets damages multiple vehicles across the defended area. Launchers, support vehicles and radar components are all hit. Specifically, the launchers were never individually detected by the F-16s, but the cluster strike blankets the entire site. With the degraded tracking solution, the interceptors fail to score direct hits, but their fragmentation warheads remain lethal. One F-16 is damaged by shrapnel from a proximity detonation. The F-16 is ultimately lost. Shrapnel from the missile detonation caused an engine fire that the aircraft could not survive. But compared to the earlier Phantom attack, the damage inflicted on the defenders is far greater. With both the search radar and the engagement radar damaged and multiple launchers disabled, the S-300 battery is rendered combat ineffective. Only 2 Buk systems remain operational. This time, the island's air defenses have been decisively weakened. This concludes the simulation of SEAD missions conducted by both 3rd and 4th generation fighter aircraft, revealing decisive differences in their effectiveness. Please consider subscribing to support the ongoing development of the simulation engine. It helps me push the project further. And if you're interested in more, including 3D models and additional resources, feel free to check out the link in the description below. Thank you for watching, and I see you in the next Combat Systems simulation.